All right, the next problem on this document, I want to look at some domain and range things because we got to start thinking of connections between functions and graphs, which is the big connection and the big deal in pre-calc, but we want to bring those ideas back up and think about them the right way to the point where when you look at something like this, you're going to see a picture in your head. And one of the big things about that is domain and range. Now, domain, of course, is the set of inputs that make sense in a function. Of course, I'm going to put that in quotes because what makes sense in mathematics is kind of a weird idea. But the inputs that make sense here in a function like this, f of x equals -1 plus the square root of x. When you're dealing with real numbers, you can't take the square root of a negative, so that would not make sense. That's one of the things to look for with domain. You got to think about the rules of real numbers, and they're not very restrictive, but they tell you you can't divide by 0 and you can't take the square root of a negative, not with real numbers. So we don't have any division, but we do have a square root there. Sometimes domain is limited by the physical situation. We don't have one of those for this problem, but we do have this restriction here. Whatever's inside of this square root, here it's just x, has to be greater than or equal to 0 in order for this to result in a real number. So x has to be greater than or equal to 0 in order to work that into here. Range is a lot trickier to think about. Range is the set of outputs that you end up with, but there's no nice little list of things to look at that this is what you might end up with. That's not how it works with range. Range is best understood after you kind of graph the function and think about what's going on with the graph of it. We'll do that in a minute, but I want to think about it sort of analytically first of all. You got the output of this square root thing is also always going to be positive. Well, the square root of 0 is 0, but otherwise it's going to be greater than 0. So -1 plus something that's greater than or equal to 0 would at least be -1 or greater than that. So the output, or the y value, is always bigger than or equal to -1. Now that's not immediately obvious, but thinking about how square roots work, you can kind of see that. So analytically, we can get to those two things. Interval form on that thing, greater than or equal to 0 means from 0 to infinity. And greater than or equal to -1 means from -1 to infinity. Those are the interval forms of that thing. So this answer choice looks good for this one. But I want to think of that a little deeper there. A little more graphically, at least. I want to think about how that would work graphically. If you know your basic functions and your basic transformations, you can get to this kind of thing pretty quickly. We've got -1 plus the square root of x. If you can think graphically about that, hey, the square root function looks like this, right? So the domain and range is built into that picture somewhere right there because you're going to start at the origin and go this way. -1 plus that, well, if you think about adding a constant to a function, that just moves all the y values by -1, right? That's a vertical shift is what we would call it in algebra and pre-calc. So you take the graph of your basic function and shift it down 1. That's going to start down here and go this way. It's just moved down 1. So that's f of x. That's the graph of it. You can read the domain and range from there on your x-axis. That's from 0 to wherever on the x-axis. And on the y-axis, it's from -1 on up. On the y-axis, from -1 to infinity on the y. So that goes right to this form if you can see the picture and think that through. That's the easy way to do domain and range. If you know your basic functions and transformations, you can do a bunch of these that way. I'm going to go ahead with number 3 because it's the same kind of question here. We got two things to think about with domain on this. This is a little more complicated than basic transformations. There's a division going on, so that's not obvious what's happening. So I don't have a basic function to work with on this. So I'm going back to this idea. The domain, first of all, is inputs that will make sense in this. So the thing inside of the square root has to be greater than or equal to 0. So that means z has to be greater than or equal to, I'm sorry, this is 0. I said 0. The inside of the square root has to be greater than or equal to 0, so that means z has to be, if I subtract 1 from both sides, greater than or equal to -1. So your input, they're using a different letter for the input here, but the interval would be from -1 to infinity. Z that's in there, but that's the domain anyway. That's your input. Range, well, what am I going to end up with in this kind of thing? That's a little bit more complicated with this going on. But I do make this the observation that the result of the square root, if it comes out 0, that would be another restriction on the domain. Otherwise, this is going to come out positive. Now, you can't divide by 0, so whatever's in the denominator here can't be equal to 0, and that means z plus 1 can't be equal to 0, so z can't be -1. Actually, I should leave that out from my domain. That's actually part of the domain issue here. The square root told me it had to be greater than or equal to -1, but I can't have that come out to 0 or I'll have a division problem since that's in the denominator. So this is true, and I should leave that out. I should really say just greater than -1 or in interval form. I'll put an open parentheses there from -1 to infinity.